All right. Well, hello, everyone, and welcome to the Future of Our Oceans webinar series brought to you by Oceans at Duke. For those of you who don't know, Oceans at Duke is an interdisciplinary network of faculty and students from a wide range of departments across Duke University who are working on issues of ocean sustainability. Our community of scholars is working together to apply cutting-edge insights from ocean science, from governance, and business to tackle the ocean's most urgent challenges and opportunities today. So for those of you who don't know, I'm John Verdon. I lead the Ocean Policy Research Program at Duke's Nicholas Institute. And I want to thank you for joining this monthly webinar series, where we're trying to explore a range of topics related to the future of our oceans, and particularly looking at the future of marine conservation areas, the role of oceans in human health, today's topic on the drivers and risks of deep sea mining, solutions for ocean plastic pollution, and the future evolution of the ocean economy, among others. And what we're doing is aiming to highlight the latest research by Duke University researchers, while at the same time engaging with external experts and stakeholders who are really connected to these challenges. And our goal is really to inform, inspire, and enable you to help ocean ecosystems and communities to flourish for the long term. So let me tell you just a little bit about the guidelines for our sessions today. This session today will be 60 minutes, and including speaker's presentation and then a question and answer session in the last 10 minutes. Now, your cameras and microphones are not functional for the session, but we encourage you to share your questions and comments in the Q&A, which is monitored by our team. And then we also encourage you to go to the Oceans at Duke website, linked to the registration that you have, in order to see additional articles or research and resources related to the topic, faculty research, and descriptions of our future webinar sessions. Now, today's session will be recorded and it will be posted to the website later this week as well. So to tell you about today's session, as many of you may know, an important policy struggle is underway internationally, one that's invisible actually to many citizens. Countries are preparing to mine the ocean floor in the deep sea, hoping to secure minerals that are deemed important to supporting a modern economy. The International Seabed Authority is required to ensure that this mining does not harm the marine environment, but finds itself caught between competing interests. On one side are countries and companies that are anxious to proceed, while on the other side, there are countries, scientists, and non-governmental organizations who are anxious to ensure adequate protections for the ocean environment and for the unique biodiversity of the deep sea. And the resulting struggle presents important questions about the future stewardship of our oceans. So our panel today includes experts in the ecology of the deep sea and in the plans for deep sea mining. We're going to provide insights into these vital questions related to the exploration and exploitation of the deep sea. Our panel today is moderated by Duke Law Professor of the Practice, Steve Rohde. Steve's an environmental lawyer with extensive experience in both policy and litigation. He's been involved with seabed mining issues now for a number of years, and most recently, he's been closely engaged with the effort by the International Seabed Authority to finalize regulations that will guide the mining of the deep seabed. So without further ado, let me introduce you to and hand you over to Steve.
Thank you very much for that introduction, John, and welcome everybody. We're delighted to be with you today to talk a little bit about this really important issue of seabed mining. And we've assembled an expert panel of 3 folks from actually around the globe, from not only from Durham, but also from the West Coast and from Australia today to talk with you about this topic. We're going to proceed in 3 parts. Each expert has a part they're going to play for us. Our first expert, Megan Cook, is going to talk with us about what it is that we actually find in the deep sea, what sort of living and non-living resources inhabit the deep ocean space that might be affected by deep sea mining. Our second expert, Elisabetta Manini, will talk with us about the kinds of management and regulatory regimes that are in place for some of these unique environments in the deep sea already. And our third expert, Renee Grogan, will talk with us about how it is that the regulators and the countries and the companies involved in this seabed mining effort are attempting to put together their plans and procedures for moving forward in a responsible way to conduct the deep sea mining exercise. But before I turn it over to our first panelist, I wanted just to give you guys a quick refresher on how it is that the world goes about governing the ocean space. If you look at this first slide, you'll see that under the law of the sea, every country actually has sovereign rights out to 200 nautical miles off its shoreline. And within this space, it's able to basically use and manage its resources, including mining of the seabed out that far. Out beyond 200 nautical miles, with certain exceptions that I'll mention in a minute, we have the deep sea. And the seabed under the deep sea, in this slide, you'll see the deep sea is shown as the areas in blue, whereas the EEZs are shown areas in yellow. Underneath the deep sea, the seabed is called the area, and this is the part of the ocean that the International Seabed Authority has been given responsibility to manage and regulate. It's interesting to note that, as I mentioned before, countries can extend their EEZs just a bit. There's a sort of a complicated formula under Article 75 of the Law of the Sea that will allow countries to extend their jurisdiction out a bit beyond the 200 nautical mile limit. But be that as it may, there are a couple of points under the Law of the Sea that are worth keeping in mind before we start in this morning. First is, under Article 192 of the Law of the Sea, every country has a solemn obligation to protect and preserve the marine environment. And under Article 145 of the Law of the Sea, the International Seabed Authority is specifically tasked to make sure that it engages in activities and procedures that effectively provide effective protection for the marine environment from the kind of impacts that might result from mining. So the ISA has a really interesting charge. On the one hand, the ISA is charged to make sure mining of the deep seabed and minerals therein can occur, but also at the same time to ensure effective protection of the marine environment, as part of that process. And then finally, I would just also note that Articles 208 and 214 of the Law of the Sea impose obligations on specific countries to make sure that any pollution resulting from seabed mining activities is controlled and monitored and enforced against. So that's the sort of the legal and regulatory envelope that we find ourselves in as we start talking about mining the deep seabed. And now I'd like to go ahead and introduce to you our first expert panelist, Megan Cook. Megan is the Manager of Education Partnerships and Programs for the Ocean Exploration Trust. She's part of a team that's investigating the seafloor and the deep ocean biome. Her team operates research vessel EV Nautilus, collaborating with the global scientific community to explore the 95% of the ocean which remains unexplored and uncharacterized. And she works across disciplines of biology, geology, marine archaeology, geochemistry, technology development, and media. She spent 8 years with Ocean Exploration Trust, and during that time, she's led her department at sea on 23 deep sea expeditions and supported over 60 research cruises. She manages a suite of partnerships at sea and onshore education programs to connect interested parties with emerging technologies, career role models, and the excitement of discovery. Before joining her current team, Megan's international career experience bridged scientific research, conservation, education, digital media, and expedition operations. And in parallel with her current professional career, she is now, at present, a Duke University graduate student pursuing a Master of Environmental Management degree within the Duke Environmental Leadership Program. So welcome, Megan. Glad you're here, and it's all yours.
Thank you so much, Steve. And thank you everyone for coming. I'm delighted to be able to share the oceans with you today. I'd like to begin by sharing that I'm connected with you from the San Juan Islands in Washington State. And I recognize that this is the modern and the ancestral homes of the Central Coast Salish people. Their stewardship of the marine environment since time immemorial makes it a beautiful place to study the ocean. And it's a wonderful place to conduct my work from, and also to be part of the Duke community. I get to take you on a journey from the dry and dusty parts of the planet where we spend our days into the ocean, which supports billions of dollars of economic activity, generates the oxygen that we breathe, supports a stable climate, and is the inspiration for our art, for spiritual connection, and for our academics. So as this is Oceans at Duke, I thought I'd start with a reference that I hope is familiar to many in the audience as we wrap our minds around the scale of the deep ocean. So imagine looking towards the spires. The Duke Chapel is an impressive 65 meters tall. And let's dive into using that to think about our ocean. For the scuba divers in the room, with some advanced training, you could scuba dive one Duke Chapel down into the ocean. By the time we add 2 more onto it, you are now at the part of the ocean that we begin to call the deep sea. 99% of the sunlight has dissipated and disappeared by the time you're at this stage of the ocean. Add 15 more Duke Chapels and you've sunk through the mesopelagic, where the largest daily animal migration on the world pulls surface generated carbon down to the seabed. We're going to need to descend 45 more Duke Chapels to reach 4,000 meters, or the average depth of the global ocean. Many of the ores we're going to discuss today will be in this depth range. However, to reach the deepest of the ecosystems I'll introduce you to, we need to keep going. We need to sink about 100 Duke Chapels down into the ocean. And to take this analogy all the way to the end, if we really want to reach the deepest parts of the global ocean, we need to nearly double that, go to 170 Duke Chapels to get us to the Challenger Deep, Marianas Trench at the bottom of the ocean. Now, keep in mind, for every single one of those Duke Chapels that we descend, you would add 100 pounds per square inch of total pressure pushing down from around. Now, despite this wild pressure, the total darkness, the impressive depth, the ocean is home to remarkable biodiversity and some of the most incredible habitats on our planet. I believe they are all the more impressive for the fact that they have adapted for all of these conditions, which to us seem so different and so strange. Returning to today's topic, though, as we think about seabed mining as a general topic, it's important to recognize there are 3 very different ore targets, and each of them are in a different ecosystem, and I'm happy to walk you through that. All of the ores we're looking at are multi-metal composites here, but for seafloor massive sulfides, those are found at hydrothermal vents and in back arc basins. For polymetallic nodules, which we'll discuss, those are found in the Abyssal Plain and across open basins of our ocean. And cobalt crusts are found on flat top seamounts, which are called geos, and conical seamounts around the world. Now, mineral ores are distributed globally. About 2/3 of the exploration permits that have been issued to date are in the Pacific, and exploration contracts have been issued for all 3 of these mineral types. But minerals are found within the EEZs of national jurisdiction and also in international waters. For an example, about 20% of manganese nodules are found within national jurisdiction rather than out in the area that Steve introduced you to. So let's visit some ecosystems. We'll pull back the water for a moment from the planet and think about, if you recall your Earth science, the skin of the planet is always shifting in tectonic plates, and those places where the plates move apart, you create new seafloor in those areas. Those are mid-ocean ridges. And that divergent boundaries, those mid-ocean ridges, are the largest feature on our planet. They wrap around Earth like the seam on a baseball, with 60,000 kilometers of mountains on our ocean. And along those mountain ridges are where we find our first ecosystem, hydrothermal vents. Hydrothermal vents are absolute oases of life on the seafloor. They are underwater geysers. They're iconic for that mineral-rich black smoke rising from these chimneys. They were discovered only in the 1970s and really transformed the way we think about life on our planet, because they are fueled in these ecosystems by chemosynthesis, the microbes' ability to transform chemical energy into metabolic energy, rather than using sunlight to do that, like we're more familiar on the surface. The ores in consideration here are the chimneys themselves, the active venting and inactive chimneys, where mineral mounds are created by hundreds of thousands of years of this venting and growth of the chimneys. These are dotted like jewels along the mid-Atlantic or the mid-ocean ridges, but most of them are quite small. A single vent would generally fit inside a college auditorium. And if you took all of the active venting habitat around the world and squished it together into one place, it would be smaller than the island of Manhattan in New York. Yet these support absolute incredible diversity of life, and their influence reaches all the way to the surface. Recent research from the Southern Ocean connects that mineral plume as the iron fertilization directly connected to a surface plankton bloom. So that rising influence from the seafloor is now directly linked to the basic food chains of our global fisheries and also to our cycles of carbon sequestration. The density of life here always just astounds me. These are seafloor metal foundries. The water coming out of these vents can be 300, 400 degrees Celsius. And yet there is this rich density of life and different life. There are distinct biogeographic provinces around the world in vents with less than 5% of species shared across all the vents. In the Caribbean, you have vents dominated by shrimp. In the Indian Ocean, snail-dominated ecosystems. In the Southern Ocean, the iconic Yeti crabs, which farm bacteria on their arms. And in the Eastern Pacific Ocean, the Riftia lipstick tube worms. I could stay on vents all day, but let's keep moving to a new ecosystem. We will head down to the Abyssal Plain now. These sedimented basins cover about 1/3 of our ocean, and this is where we find manganese nodules. These are maybe less showy as an ecosystem, but there is remarkable diversity in these areas. A lot of that diversity comes in the myofauna, which are the tiny creatures you can see in the upper right of the image, compared to a US penny. The polymetallic nodules we find here are like cobbles in the seamount. They are roughly potato-sized accretions that either sit on the surface of the sediment or embedded in the top layers of the sediment. Nodule density varies. The two images in the upper center are the Clarion-Clipperton Fracture Zone in the lower image and the Cook Island Exclusive Economic Zone above. And the diversity of life also varies with that density of nodules. We find many species here that rely on the nodules themselves, actually using that hard platform of a nodule to grow off of, like sponges or the stalk that this anemone with 8-foot-long tentacles is attached to. And we're still encountering dozens of new species each time an expedition will go there. Many organisms here are suspension feeders, so they are collecting sinking food particles from the surface and transforming that sort of drizzle of surface generated carbon into long-term storage on the seabed. Nodules accrete slowly at a dissolution rate of sort of millimeters per million years. So took a long time to create these ecosystems in the form we see them now. Moving on to our third ecosystem, I want to take you to seamounts. The global seafloor is dotted with ancient volcanoes, more than 11,000 seamounts in total. The ore here, the cobalt crust, is laid down over the top of seamounts and encrusts over rocks. You think about this sort of like frosting on a cake. It is a layer above the rock that was already there. Seamounts can be conical or they can be flat topped. These geos are largely the target of contracts right now. It would be easier to operate a vehicle in that place. But we know these mountains in the ocean are also hotspots for biodiversity with their steep gradients of slopes and the swirling currents that are generated around their heights. Seamounts are well known particularly for coral and sponge garden communities. Think about these like forests of corals on the top of a mountain. And these corals rely on that hard crust. They have to have that stable platform to grow from. Corals are ecosystem engineers. They create the structural habitat for many other species in the same way trees would work in a forest. They're also the habitat for a lot of juvenile fish that are commercially important, and many seamounts in national waters and in the high seas are already actively fished. So from a management perspective, some potential multi-sector challenges there. One spectacular thing to note about these ecosystems is just how long-lived they are. We have corals here, individual corals, Leopathes, which is the coral in the left in the center. individual animals aged to be over 4,000 years old. That means that animal settled and began to grow about the time Babylonians invented math. So we're talking massive timescales, living entirely in the dark in these ecosystems we're just starting to get to know. Ahead of our conversation today, I wanted to introduce how mining will take place in the seabed, although there's certainly regulation still in development. So a general idea to guide the conversation. There will be a collector vehicle on the seabed itself. The vehicles that you see there are from the Belgian company GSR on the top, Nautilus Minerals, and the Japanese state-owned commercial company or state-owned corporation, JOGMEC. For scale though, look in the middle image, the Nautilus Mineral image, and you'll see two people wearing green reflective jackets. So just to get scale, these are absolutely massive. Think of large scale terrestrial mining or construction equipment, and you're getting in the right realm there. So these vehicles would travel to the seafloor, be lowered down, and then they would crush, cut, or vacuum the minerals off of the seabed along with the surface sediments there, along with any animals in the way. These vehicles traveling across the seabed will generate a plume and kind of a wake. You could think of that as kicking up. And then the ores will transport up a vertical riser to a surface supply ship. They'll be dewatered there, and the ores will travel onto a barge and move to shore. That processing and sort of additional steps are beyond the scope of what we'll discuss today, but important to know that that work will actually happen ashore. And then the water, any sediment from it, any dissolved metals that have been separated from the ore will then be returned and redeposited to the ocean. This second plume will be a much larger plume, sort of a dust storm of a plume. And we're still determining regulations about the depth of discharge. And there are different environmental concerns based on how that ends up working out. Some of the concerns at a shallow discharge in the shallowest 2,000 meters would be interacting with important human fisheries, including tuna and salmon, which use water down to those depths. Although discharging at a deeper depth also has concerns for the idea of increasing the sedimentation in a landscape where animals are used to communicating through very clear water with light, and also where many animals filter feed to gather their particles, and what increased particles may do there to larval transport, but also many interesting questions about engineering and how the design of these different tools and the decisions of these different regulations may impact those impacts. Mining on the seabed will, without a doubt, impact the seabed and the ecosystems there. In the late 70s, a test study was developed dragging a trawl through the Peru Basin to simulate mining impacts. Over the next 3 decades, expeditions have continued to visit back there and look at how things have changed over time. 3 decades later, geochemical processes and species diversity have still not returned to the baseline. And one thing that I would note here is, even in this trawl image where you see the nodules sort of overturned and back into the sediment, a buried nodule is not available to be the same habitat structure that a nodule on the surface would be, as far as settling and regrowth of many of these organisms. The deep sea is a truly spectacular place, and we are just continuing to learn and discover the diversity of life there and to understand how the ecosystems function. They support our well-being as humans back up here on the dry, dusty parts of the planet. And I find this to be a just fascinating conversation as we think about it. I really look forward to the next presentations and to answering your questions. Thank you for letting me rush through the largest habitat on Earth and tell you a little bit more about it. But we'll hand it back over to Steve and look forward to the rest of the conversation.
Thank you very much, Megan, for that highly informative review of what we find in the deep sea. I'd like to introduce our next panelist now, Elisabetta Manini. Elisabetta is a second-year PhD student at Duke's Nicholas School of the Environment, and she's co-advised by Professor Cindy Van Dover and Pat Halpin at Duke, both of whom are themselves leading experts on the deep sea. Elisabetta has a background in marine biology and marine spatial planning. Her PhD focuses on the conservation of the deep sea environment and hydrothermal vents in particular in the context of deep seabed mining. In September of this year, Elizabeth was going to serve as a moderator for a special session on spatial planning in the deep, lessons learned and new opportunities at the 16th Deep Sea Biology Symposium. The submission for abstracts for this presentation is April 30, by the way, and Elizabeth is hoping to create a place of discussion and collaboration between environmental managers, scientists, and policymakers to improve environmental-based management in the deep sea. We're going to go ahead and post a link to the abstract submission on the Oceans at Duke page when we're done here. So to talk to you about measures that are being taken now in terms of managing some of these areas in the deep sea, I'm going to turn it over to Elizabeth.
Thank you, Steve. Thank you, everybody, to be here with me as well. Thank you, Megan, for the beautiful images that you showed us. I'm going to talk about deep sea mining and area-based management tools across jurisdictions. I'm going to show you what is the current state of the management and protection of the deep sea environment. So when mentioning seabed mining and area-based management tool, the first thing that comes into mind, at least to whom is familiar with the topic, is the exploration control area, and here in the figure, and the regional environmental management plans implemented around them by the International Seabed Authority. Currently, the only ramp plan established is on the Clarion-Clipperton zone in the Abyssal Plain on the Pacific Ocean. And the ramp manages the exploration of polymetallic nodules and is composed by 9 squares measuring 400 kilometers each side, where mining is not currently allowed. These areas of particular environmental interest surround the exploration contracts and should be large enough to maintain minimum sustainable population size and regional connectivity. But as Megan showed us, the deep sea doesn't have, the environment doesn't have jurisdictional boundaries. So the mineral resources are not only founded on the area. And here in this figure, you see how the polymetallic nodules, cobalt crust, and polymetallic sulfide actually overlap both in the area and in the exclusive economic zone. So therefore, at national level, there are already some area-based management tools that at least encompass at least one of these key deep sea environments. And this map shows them all together. I apologize for the Mercator projection, which showed the correct shape and direction, but I had a big distortion on the poles. And so the Antarctic Treaty area, that is this big square below the 60 parallel south, will look huge and ugly for the rest of the presentation. But if you, for your information, this area actually bans seabed mining until 2048. But zooming in the map, this map shows all the exploration control area in red and orange shades, and all the area-based management tools that encompass the key environments in a blue shades. The dark blue areas here are all area-based management tools that are implement a cross-sectoral approach and that include overall protection of the environment and a mining prohibition within the 200 nautical mile boundaries or in a different boundary. They're usually designated as MPAs, so marine protected areas, national monuments, or marine conservation areas. While the light blue here are also within 200 nautical miles, and they are mainly area implemented for fisheries management that allow and regulate, or they never consider mining in their management plan. This is because of interest of the country that implemented, or because they have been implemented under Fisheries Act and not under Conservation Act. So most of them are in the Pacific Ocean, as you can see, and I want to just highlight a couple of them. So interesting is the New Zealand benthic protection areas that protect all the benthic environment from deep sea trawling. And another interesting case is the Cook Island Marine Park, where all the exclusive economic zone is actually a marine park. However, in the light blue area, mining is allowed. So the Cook Islands in particular have these 50 nautical miles boundary that designate a full protection areas around the islands where mining is not allowed. While outside, it's always within the limits of the marine park. It's currently granting exploration license for polymetallic nodules. Another thing to notice in this map is the fact that in the area beyond national jurisdiction, there are different types of area-based management tool in place. There is the Clarion-Clipperton Zone APAs or REM planning that I showed you before. That is the only one that actually protect from mining. While the others that are now identified by the black circles and the Smurf color are established by regional fisheries organization or a regional convention that do not have a jurisdictional right to implement no mining measure in the area. But they are protecting the deep sea specifically, and in particular, vulnerable marine ecosystem, which coincide with seamounts and hydrothermal vents that Megan showed us how beautiful they are. So here I'm going to talk a little bit more about hydrothermal vents and area-based management tools. The protection of hydrothermal vents is one of my principal focus of my PhD. And I just updated my inventory, which with the latest available data. In the last 3 years, actually, the area-based management tool that includes hydrothermal vents within national jurisdiction expanded. So now, the number is up to 26 area-based management tools that varies on type of designations, of course. So some of them are very small here, so it's difficult to see them, but most of them protect hydrothermal vents from mining. And the one that they actually have a possibility for future stricter conservation. So here, right now, we have almost 20% of the hydrothermal vents that are managed, and 12.5% is actually protected from mining, which are 83 vents. Still, all of these protected hydrothermal vents will probably fit just into a soccer field because of their rare as small natural feature. And they are protecting only within the national jurisdiction by 14 countries, and within 200 nautical miles, in any case, by 2 international treaties. So no hydrothermal vents are currently protected in the area where seafloor massive sulfide deposits are currently in exploration. However, one of the latest publication of the ISA is a proposal for the new regional environmental management plan on the north of the Mid-Atlantic Ridge. The Mid-Atlantic Ridge is well known for the diversity and the importance of active hydrothermal vents, seamounts populated by corals, and other important ecological features. The plan applies the proposed plan applies 2 different area-based management tool approach based on the vulnerable marine ecosystem criteria and the site criteria adopted for identify ecological and biological significant areas. So we have a fine scale approach and a broad scale approach. The fine scale approach actually identifies 11 active hydrothermal vents sites as sites in need of protection that are currently within the contract license. While there are 12 sites in need of precaution that are inferred vents, and the broad scale identify 3 areas that are fractum zone systems along the Mid-Atlantic Ridge, and an area that is identified by habitat coral suitability models that is depicted here in this square. So our take-home messages here is that deep sea management is actually growing, and the protection of deep sea is growing as well, highlighting how the deep sea is getting more recognition on its importance. The type of management measures, of course, they have to be adapted on the type of the habitat that we have, as we saw, like the difference between the Clarion-Clipperton zone and the new ramp, the new proposal of the ramp planning, and it changed from the type of knowledge that we have available. And it's good to see that lesson learned from other type of area-based management tool or scientific and technical exercises such the EBSA are applied in creating or like proposing new management measure, which brings opportunity of collaboration and harmonization between the governance body. So thank you very much for listening. I will pass Steve, that he will introduce the next speaker.
Thank you very much indeed, Elizabeth. A fascinating review of the kind of management tools available currently for these areas of the deep sea. Let me introduce now our next expert, Renee Grogan. Renee is an environmental consultant with more than 14 years industry experience in environmental management, including operational site management, compliance, permitting and approvals, strategy and project management, risk, feasibility, and previous feasibility studies. Her experience includes working in Australia and the Pacific, the United States, Africa, and parts of Europe. She has extensive experience in the extractive industry, including phosphate, coal, gold, copper, tungsten, lead, and manganese. Her experience traverses both terrestrial and deep sea mining environments. And since 2014, Renee has actually specialized in deep sea mining, providing advice to mining companies, intergovernmental agencies, and non-governmental organizations. Renee comes from a strong industry background. She fulfilled senior environmental management positions with several companies, including Nautilus Minerals and Newcrest Mining Limited, as well as Goldfields Limited and Thice Mining. Her responsibilities included permitting and approvals, regulatory compliance, international and domestic stakeholder engagement, and continuous improvement of operations. She's also director of the World Ocean Council and of a group called Bottle for Bodle, a charity aiming to reduce the use of single-use plastics in Australia and Indonesia. Renee, thank you so much for joining us from the middle of the night in Australia. We're greatly in your debt, so over to you.
Thanks very much, Steve. And thanks to Betta and Megan for those fantastic talks. I'm going to build a little bit on the concepts that Megan and Betta spoke about, and I'm going to talk really briefly about how the regulatory frameworks and how the science of the deep sea play into the challenges that industry have in achieving responsible seabed mining. This is a really big topic and I have 10 minutes, so I'm just going to touch on a very few brief issues. So the first thing in relation to regulatory frameworks is, as Betta mentioned, there are two different areas for consideration, the EEZs of various countries and the area. The International Seabed Authority, or the ISA, is still developing the regulatory framework for regulations in the area, and obviously we have some draft regulations for exploitation that are currently being assessed. Within EEZs, the governments obviously have the potential to take their own approaches, and some develop entirely new legislation, such as in the Cook Islands and New Zealand, which is really specific legislation to the deep sea and to deep sea mining, while others, such as PNG and Namibia, take existing terrestrial mining legislation and apply it into the deep sea. There are benefits to both approaches. And most importantly, the real benefit is the maturity and the experience of the regulator, where you have a regulator that already implements legislation for an existing industry, such as terrestrial mining or oil and gas. So the whole point of a regulatory framework in relation to industry is to create a level playing field, so that you have all players subjected to the same standard of operations, the same requirements, the same penalties, and you effectively achieve a standardization of how various different proponents carry out their activities, in this case, mining of the deep sea. One of the most important ways to achieve that is this concept of the maturity and the experience of the regulator. So the experience that a regulator has in working with proponents, in interacting in relation to the development of environmental impact assessments, scoping of studies, the peer review of studies, the stakeholder review of studies, and the development of management strategies. These are all really challenging processes that often involve hundreds of stakeholders from many different groups with many different agendas and issues of concern. Often there's conflicting legislation or complementary legislation, as Megan touched on, from industries like fishing or oil and gas. And the maturity of the regulator plays a really big part in managing these issues and also in enforcing them. So the concept of that level playing field being implemented and really holding the proponents to a particular standard across the board. The other thing that's really important in relation to the regulatory framework is the concept of enforcement instruments. So almost every regulatory framework has theoretically enforcement instruments. These could be the concept of removing your permit to mine or cancelling your permit to mine if you don't comply with the conditions of your permit. Obviously, fines are quite a common enforcement protocol, temporary suspension of activities. It's important to note that of all of these, the suspension of activities carries the biggest financial penalty to a mining company. The downtime or lost production time is a much bigger financial penalty than a fine. But the really critical thing here is the concept of, firstly, whether the instrument exists. And as I said before, mostly they do in pretty much every regulatory framework, including the ISA's proposed exploitation regulations. But secondly, whether these instruments have ever been used, whether there's a precedent. And this is important in terms of providing a pathway for the regulator to show this is how you do it, this is how you achieve this kind of enforcement, but also to demonstrate to other proponents that this is the stick, I guess, as opposed to the carrot, that these kinds of enforcement activities can happen and that this would drive behaviour in proponents in terms of doing the right thing. And then the second thing in relation to enforcement is obviously the resources that you need to enforce these kinds of instruments. Now, in the terrestrial environment or in the oil and gas industry even, it's a much simpler approach quite often to enforce an instrument such as this, because you're sending out an auditor, a government agency representative to inspect the operation and to deliver, in some cases, a stop work notice or an infringement notice. And that's quite a straightforward process. There's lots of precedent throughout many industries for this kind of thing to occur and to be enforced. However, once you are in the deep ocean and you're several thousand miles away from the nearest port, this becomes a much bigger challenge in terms of resourcing. And this is a really critical issue for the ISA, which is the regulator in the area, in terms of, okay, you have an instrument, how do you enforce it? How much does it cost to enforce it? What are the logistics involved in enforcing it? And how do you propose to finance that process and to bring the proponents into line when they're in a place where it's very hard to get to, it's very hard to see what they're doing, and you have many logistical challenges. So these are some of the many things facing the regulators across the board, and the industry is really focused on this, as I said before, in terms of understanding the concept of a level playing field, but also understanding the constraints and the limitations to the mining process. The second thing I want to really briefly talk about is the concept of scientific studies in the seabed mining world. As Megan very clearly showed, there are some incredible environmental values in the seabed environment. And we have, when we start to think about studying these areas, particularly areas that have never been studied before, we start to come up against some really challenging issues. The first and most obvious is that when you're looking in a place where you've never looked before, you're going to find things you've never seen before. And so we see a huge majority of species being new to science, particularly in areas around nodules in the Clarion-Clipperton zone and other nodule areas. But also we see a huge challenge in terms of the logistics of gathering science and information, but also because of this being such a new industry, there is a real challenge around how do you use that science and what are you trying to achieve by gathering that science? So most of the regulatory frameworks that I talked about before have some guidance on what kind of studies you need to do to inform an impact assessment or a study for a new mine. But there's still quite a long way to go in terms of really understanding the bigger picture of using the scientific data that you gather from the seafloor at great expense to the best advantage in terms of creating a responsible mine plan. And this is something that proponents quite often don't have a lot of experience with. In a terrestrial mining operation, there's a lot of experience in terms of marrying science up with the mine plan, for instance, and really using the data that you gather to manipulate and change your mine plan to a point where you have an approach in terms of both the methodology that you're using, the equipment that you're using, but also the areas that you're mining. So you might have a contract area and the science is telling you that a third or a quarter or several aspects of that area should not be mined because they contain the greatest environmental values, or they contain environmental values that cannot recover from the kinds of impacts that you're looking at having on that ecosystem. So the real challenge here is to say, okay, what are you trying to achieve? You have a plethora of guidelines on data that you should collect, but how do you use that data? And one of the things that I talked about when I spoke with the other panelists was, this concept of can you protect the environment or the ecosystem without fully understanding it? And all the scientists in the discussion went, "Ooh, that's a very interesting question." And I think for understanding deep sea mining impacts, it's a really critical question because arguably we will never fully understand the ecosystem. So what do we need to do and how do we need to use the science to identify the areas that we consider are valuable, either in relation to their habitats or their communities? And how do we make informed assumptions about those habitats and their communities, how they're connected, what their life cycles are like, their genetics, the impact that they have, as Megan said, on other aspects of ocean health. And all of these things are really challenging and need really robust science in terms of both identifying the values, but also making the assumptions where we know we're not fully going to understand. And then the next thing is this concept of impact models, which I could talk all day about, but the only thing I will really say is that there is the capacity to develop impact models in terms of plumes and habitat impacts and the things that Megan talked about. But these need to be really robust. As everybody would know, what you put into a model in terms of data and assumptions will really influence what comes out of it. And if you're going to use models to predict either where your environmental values might be across a really broad scale, or how large your impacts are going to be across that same scale, then those models need to be very, very robust. And that's a challenge for industry at present, particularly because sometimes these models are considered intellectual property that's not shared. And so some of them are great, some of them are not so great. And the public review of these models is sort of still a work in progress. Lastly, I guess the concept that I want to return to is of science influencing the mine plan. And this is a really critical issue. Again, returning to terrestrial mining, it's a very well embedded concept, and it definitely applies to the deep sea. So an understanding of the scientific values in the deep sea should absolutely implement changes or manipulations to your mine plan. So this looks like the geologists and the mining engineers working with the environmental scientists to say, okay, well, how do we economically mine this resource? But then also, how do you protect the really important environmental values? And that might mean, as I said before, things like exclusion zones, areas that you don't touch. It might mean that you don't mine at all during a particular time of the year when coral spawning happens or when fish spawning happens. And this is the way that the science really should impact on the mine plan on an ongoing basis, so that you're working towards this concept of responsible seabed mining, and you're not just saying this is our mine plan and this is where we're going to go. This for me this is the work that I do. I find it really challenging and really interesting to work with industry in terms of balancing this concept of what you're required to do by the regulatory framework, whether it be weak or strong, established or new, and this concept of thinking big and really saying, how do we do this in a responsible way and how do we use the science to inform the discussion? So I'll leave it there.
Thank you very much. Thank you very much, Renee. It's a wonderfully thoughtful review of some of the problems people are facing as they proceed with the seabed mining process. This concludes our panel presentation, and I think now we have a few minutes for questions. I'd like to roll the microphone over to Doug Nowacek. Doug is a distinguished professor at Duke who has a joint appointment, I guess, with the engineering school and the Nicholas School. He's a distinguished professor of conservation technology in both environment and engineering. And he's going to, I think, MC the Q&A session. Doug, over to you.
Yeah, thanks, Steve. And thanks to all of you. Thanks to everybody for attending, but especially to our panel. So generated some really interesting questions. I'm gonna jump right to them. I'm going to try to sort of amalgamate them a little bit, but just to remind everybody that if we don't get to the questions that you've submitted, they'll get passed along, and our panelists have graciously agreed to address them later, and they'll also be referenced on the website. So let me just start with one that, and feel free to any of you jump in. Some of it will be obvious, but then others might not be. I'm going to combine a couple questions here. One question about enforcement under the UN Law of the Sea. So who is in charge of enforcement under the UN Law of the Sea? So and while we're the related one is specifically for the International Seabed, but I think actually what I'll do, I'll let you answer that one because there's a pursuant question to it, but let's start with that, the Law of the Sea and who's in charge of it.
Should I just jump in, Renee? What do you think? Well, under the Law of the Sea, the arrangement is if you're a signatory to the Law of the Sea, and as Renee reminded us this morning, the United States has actually not ratified the Law of the Sea. Most every country in the world has, the US has not. But if you have signed and ratified the Law of the Sea, you agree to be held accountable in some international tribunal, either the International Court of Justice or some arbitral panel or the International Law of the Sea. You agree to make yourself subject to jurisdiction in case there is a problem with what you're doing. So in theory, if there's a problem that arises under the ISA that people think are in violation of an article like 145 or 192 or 214, the countries who are involved in that fracas can be held accountable in an international tribunal. This is all new, as Renee pointed out, and so none of this has ever been put to a test, and there's actually a specific exemption in the Law of the Sea that basically allows the ISA a lot of discretion in what they decide with respect to various contracts. So a lot of this enforcement in front of the ISA remains to be sorted out, and in fact, some parties have been advocating that the ISA set up its own separate sort of internal review process by way of helping to sort out some of these enforcement questions. But it all remains pretty open to discussion. At least that's certainly my impression, Renee.
Any other thoughts on that? We'll move on to maybe to the pursuant ISA question, which is a little more specialized, and that is if the ISA fails to adopt the regulations. One of the attendees has referenced a 2-year trigger, and whether if the ISA fails to adopt the exploitation regulations and this 2-year trigger is invoked, is the ISA obligated to approve those permits? And the question and concern, obviously, of how to make sure that the permitting process isn't circumvented.
Renee, do you have thoughts on that? I'm happy to let you go on this one.
Yeah, sure. So the 2-year trigger relates to the finalization of the exploitation regulations. It doesn't require the ISA to approve any permit applications. It requires the ISA to finalize and formalize the regulatory framework that will allow those applications to be assessed. So that's quite an important distinction. It doesn't guarantee that the application that is a part of that trigger will be approved. It simply requires the formalization of the framework to allow that application and subsequent applications to be assessed by the ISA.
I think that's a really valuable point to make. Thank you, Renee. And also, I would note, and Renee knows this probably better than anybody, these exploitation regulations have been a long time in the oven. They're still working through the ISA. There's a fair amount of controversy among the countries, member countries of the ISA, about some of the provisions or lack of some provisions in these, the latest draft of the exploitation regulations. So we'll see. But the questioner obviously is wondering what happens if this trigger mechanism is invoked. In which case we will, I suppose, end up with something called exploitation regulations. The question is going to be what's in those regulations and whether we have supplemental standards and guidelines that come out and so on and so forth. But it is important to note the distinction between approving the regulations and actually signing off on an application.
Excellent. That's very helpful clarification. I think it's just what that questioner was after. So good. Next one is on actual mining methodologies, and probably, I guess, for Megan and Torbetta, but you feel free to answer as you like. The question is about, are there preferred or low impact methods for mining, and I guess just a general question on methodology. And one specific sort of follow-up came through on plume management and plume impact and development of best practices, technologies, institutions, and that sort of thing. So methods and specifically on plume management. Thanks.
Sure, I'm happy to start a little bit there. I'd just say that all of this is in development. Part of the exploration stage is the testing of technology. Extremely topical to right now, there is a test from the Belgian company GSR happening in the Clarion-Clipperton fracture zone over the next month or so, testing a vehicle. If you're interested in learning more about this research, there's a group in the engineering school at MIT that's focused specifically on, they would hate for me to call them spoilers, but different formations and different shapes of the vehicle to think about how you can minimize the water disturbance caused by some of these things. And then there are different industry applications coming for different levels of that impact. Could you bubble net your riser pipes to reduce sound? Are there different ways to, what is the size of sediment that'll settle the most quickly, if settling the most quickly is the goal for your plume? So there is a lot of research out there right now, and I'd encourage that during this exploration phase. I would just add that all of this work does have an environmental impact assessment that is done to it. So those documents are also available for many companies to take a look at the modeling that has happened. For example, for that GSR cruise, there is a parallel EU-funded science expedition that will be tracking and moving along with that vessel and looking to cross-check the models, looking to understand if what we think will happen will really happen on a very small patch test during this exploration stage. Learning a lot more right now.
Very cool. Thank you, Megan. We just have a couple minutes left, and I'm going to ask Dan Vermeer to launch the poll. And this is just so we get a sense, and everybody gets a sense of what associations people are coming from and what connections they have. And while you're filling out that poll, I will go on to another question, which is probably for Renee, but it's about the incentives and carrots and sticks having to do with sticking to your permits and things. And there's a question specifically about bonds, about having companies having to issue bonds before the industry start mining. And so I guess there's just some more interest about other ways to ensure permit compliance.
Sure. The concept of bonds is really well established in terrestrial mining. So what a bond is the company pays an amount, it's either a guarantee or a cash equivalent, to the regulator, and it's held in trust with a bank or a financial institution. And that amount is typically allowed for rehabilitation of the mine should the company go bankrupt or go into receivership or not be able to implement its rehabilitation under its own steam. So this is quite a common, it's common in almost every regulatory framework for terrestrial mining. It has its own challenges, but it's a way to sort of require a proponent to put the money in the bank for rehabilitation activities, should they not be able to do it or should they run into financial trouble. The challenge in the deep sea is several-fold. Firstly, the concept of rehabilitation is a tricky one, and it's very much more difficult to achieve rehabilitation targets, as Megan showed, particularly in nodule environments. This concept of recovering the environment within any kind of reasonable timescale is really challenging and many would say impossible. And so the concept of putting money aside to achieve something that's not feasible is a challenge. And then the other concept that has been talked about within the ISA framework is the concept of a bond type approach for environmental incident management. So if there happened to be an oil leak from the ship or an unplanned impact, then the bond could be used, or a similar mechanism could be used to manage the cleanup of that kind of an impact. But that's not really the same as a bond in the sort of traditional sense. So this is a really big, it's a really big deal in terms of getting the impact assessment right. So as a mining company, you say, well, we think our impact is going to be this big, and you get approval or not of an EIA on that basis. So in the terrestrial world, if your impact is bigger than that, then theoretically you can throw a lot of money at it and you can do something to fix that. In the deep sea world, if your impact is bigger than you said it would be in the EIA, then the challenge around what can be done about that is really very significant.
Right, right. Well, thank you very much. We are already past time. So I think just in the interest of sticking to everybody's schedules and not imposing too much, I will ask John Verdon to pop back on. You folks can probably see the poll. We're delighted to have such an interesting and diverse array of attendees. So thank you all for attending. And again, thanks to our panelists, but I'll hand it over to John.
Thanks, Doug. And let me thank the panelists, all of you again, so much. So what a fascinating discussion that's going to be really critical to the future of how we use so much of the ocean. So really, really appreciated it. I know I learned a lot. And I'd like to thank all our audience as well. I hope you found it useful, and hope that you're also going to return to hear more in the next month and join us on May 11th when Dr. Megan Dunphy-Daly and colleagues are going to share some work on plastic pollution. And of course, in the meantime, please don't forget to check out the Oceans at Duke website for details on any future webinars, recordings of this session and other past sessions, and sign up for our newsletter. So thanks to all in the audience for taking the time to listen today. Thanks so much to our panelists for such a wonderful and insightful discussion, and look forward to seeing all of you at our future Oceans at Duke events. Thanks, everyone.